study the reactions of metal with chlorine. Now, why only chlorine? The chlorine, an important non-metal, it is a very important non-metal, reacts with almost all the metals. So let's study the starting few metals, starting with Na. Metals react with chlorine. Why do metals react with chlorine? Metals are electropositive in nature and chlorine is highly electronegative. So metals can donate one electron and chlorine can accept those electrons to form ionic chloride. So sodium is a metal. Naturally, metal is going to readily react with chlorine to form an ionic chloride called sodium chloride. So when Na reacts with Cl, it reacts with a Cl2 gas. So gases are diatomic. So remember, Na plus Cl doesn't give me NaCl. Na plus Cl2 will give me NaCl. Why NaCl? So why not NaCl2? Because Na is valency is 1, Cl's valency is 1, crisscross NaCl. Now to balance the reaction, Na is 1 on the left hand side, 1 on the right hand side. Cl is 2 on the left hand side, 1 on the right hand side. What would you do? You have to multiply by 2. Na becomes 2, multiply by 2, the reaction is balanced. Sodium chloride, a very important ionic chloride. Where do you use it? You already know, everybody knows, it is the common salt which we use almost daily, which we eat almost daily. More of this. Calcium is metal which reacts with chlorine to form ionic chloride called calcium chloride. Now calcium has to react vigorously with chlorine. Calcium reacts with Cl2. Over here, calcium's valency is 2, Cl's valency is 1. What would you do? Crisscross, it will form CaCl2. In this reaction, you'll see that the reaction is self-balanced. So metals react with chlorine. Let us see a few more metals. When zinc combines directly with chlorine to form zinc chloride. Zinc is a metal. It is going to give electrons. Chlorine is going to receive electrons. So zinc reacts with chlorine. Zn plus Cl2. No algebra, but still zinc's valency is 2, Cl's valency is 1, crisscross, ZnCl2. The reaction is already balanced. Zinc chloride, another ionic compound. Iron combines with chlorine when heated to form iron 3 chloride. Now, why? What is this reaction? Let us see first the reaction itself. Fe plus Cl2 is going to form not FeCl2. Iron's valency is 2 as well as 3. But iron does not readily react with chlorine. So in order to make him react, we have heated it. So the valency from 2 continues to 3, which is its excited state. So iron reacts in the valency of 3. Chlorine has valency 1, crisscross, FeCl3. This is known as ferric chloride. Normally, if it reacts with valency 2, it is called as ferrous. So this is ferric chloride. Fe is 1, Fe is 1, Cl is 2 and 3. 2 and 3 dilemma. Odd ko banao even. Multiply by 2 on the left hand side, multiply by 3 on the right hand side. Fe becomes 2 on the right hand side, so multiply by 2 on the left hand side. The reaction is balanced. Let's study now the reactions of metal with hydrogen. Most of the metals do not combine with hydrogen. Why? Hydrogen is a non-metal just like chlorine. It isn't. Hydrogen is a positive ion. Usually, hydrogen tends to give electrons. But being its electronic configuration just 1, it can also accept electrons. So only a few metals react with sodium, react with hydrogen, that is sodium, potassium, calcium and magnesium. Why do they so? Because they are highly reactive and they can pass their electrons to hydrogen, but not other metals can do that. So when hydrogen gas is passed over heated sodium, then sodium hydride is formed, Na plus H. Over here, H is diatomic, so always remember H2. It is going to form NaH2. No, I'm wrong. Na valency is 1. H valency is 1, crisscross, NaH. Remember, Na is giving electron to hydrogen. It rarely happens, but it does happen. Similar to that, let's see the reaction of calcium Now you'll see that sodium has to be heated. Why, sir? It is already so reactive. Over here, sodium has to give the electron to hydrogen. So does calcium have to give the electron. So in order to give the electron, it has to go to its very heated form. Ca reacts with H. H2, Ca valency is 2, H valency is 1, crisscross Ca, H2, and that is how metals react with hydrogen to form sodium hydride, calcium hydride, potassium hydride, and magnesium hydride. These all are ionic hydrides.